Okay, I'm back. I'm still at the bottom of page 221. I just want to reiterate, you should definitely try this, right? You have a lot of time on your hands, maybe. Go to geogebra.org, click on GeoGebra Classic, get it going. The previous video is all about that. It's the best way to learn and get oriented with these sorts of things. So I can't recommend it enough. So go do that. But let's go on. So some things in 3 dimensions. So we've already talked about this a little bit. In particular, when we were deciding where those points lived, right? I made some sort of generalizations that maybe you picked up on, maybe you didn't. So if we have the xy plane, the variable that's missing is z, which means that that equation of that plane is actually just going to be z equals 0. I'm going to change colors. And in a room, in general, that's going to be the floor. Okay. The next type of plane, the xz plane. So what's missing? Y is missing, so the equation is going to be y equals 0. And then if you think back to that picture that we drew before on the first page of the notes, if you're looking for the xz plane, so it kind of, you have this, this, this. Oh, God. This. Okay, so you have that, right? And then this is x, this is y, this is z. This right here is the xz plane. But remember, you're standing here and you're looking there. So this is actually going to be to the left, right? This is the wall to the left. If you're in a standard room that has walls, it'll be the wall on your left. The next plane is the yz plane. So the yz plane, what's missing? X is missing. So the equation will be x equals 0. And there's really only one thing left. If you go back to this amazing picture, if you go back to this amazing picture, then it's going to have to be the wall that's on your right. And you can see it's y and z, right? So the yz plane. So that's going to be the wall to the right. Had I known that I was going to have to write on an iPad, I would have gotten better handwriting along the way somewhere. I don't think that's true. But I could have put a little more effort into that, and I do regret it. I don't actually write that much. This is the most writing I've done in ages. Okay, whoa, what is happening? All right, so there are other sort of like easy-ish planes, and those are the ones where you just take one of the variables, x, y, or z, and you set them equal to 0. So there's kind of a fun little fact about that. So x equals 0, the best way to learn this is really just fire up GeoGebra. X equals 0 is the yz plane. X equals 10 is therefore going to be parallel to the yz plane. It's another plane parallel to the yz plane. Y equals 0 is the xz plane. So y equals -5 is just going to be a plane that is parallel to y equals 0. Therefore, it's parallel to the xz plane. So that's what we want to do. So there's only one, this bothers me. There's only one type of horizontal plane. Every horizontal plane that you see will have the equation z equals a number. So z equals 0 is the xy plane, that's like the floor. I don't know how high your ceiling is, but say it's like 8 feet. So z equals 8 is another horizontal plane. The floor below you, z equals -8 maybe. Horizontal. There's only one type of horizontal plane. There's actually an infinite number of types of vertical planes. So the easiest way I think to imagine it is imagine that you take a book, right? So you just have a book, you put it so its spine is up, and then fan out the pages. So maybe your notebook is like this, fan out the pages. Each of those pages could represent a plane. So you can tilt them, you can rotate them, and keep them vertical. Infinite number of types of vertical planes, only one type of horizontal. It doesn't really seem fair, but that's the way it works. So let's see what we can do. So parametric equations, you will find, are incredibly important for this. Why are we not updating? Hold on. Let me drop out of this. Stop mirroring. Let me go back in. Here. Okay, I think we're back. Okay, are we back? Yeah, we're back. Okay, so parametric equations, super important. Let's see if we can do this. So what I want to do is I'm just going to describe some things, right? So we're going to be in the plane x equals 2. The plane x equals 2 is parallel to x equals 0. So this is the thought process. It's parallel to x equals 0. X equals 0 is the YZ plane. So you always go in alphabetical order for, I don't know, consistency. It's just what we all agree to do. Now I'm just going to list 4 points that are in this plane. Well, all right, so I know that x is going to be 0, and let's say we're in the first quadrant of that. So y and z should be positive. Let's say x is 0, and then let's be in the second quadrant of this weird plane, right? So we're not in the YZ plane, we're in a plane parallel to it, but it has its own 4 quadrants. So I'm going to make y be negative and z be positive. And then x will be 0. I'll make them both negative. -5, -4. Just be systematic about it. And then 0, and then x has to be positive. Let's go with 10, and y has to be negative. Let's go with -8. Okay, so this would be like quadrant 1. Ew, what? It's not really quadrant 1. It's quadrant 1 of the plane x equals 2. This would be like quadrant 2. And you could fill in the rest if you wanted to. All right, so the next thing we want to do, we want to be in the plane y equals 5, and we want a circle that's in that plane. So I'm going to say the plane y equals 5 is definitely parallel to the plane y equals 0. Okay, so now think about it. How do I parameterize a circle, right? So it's, well, okay, I didn't finish this problem. Y equals 0, which is the xz plane. Okay, so now let me just draw a circle, right? So, but I'm going to draw it in this plane. Well, actually, I'm going to draw it, get out of there. I'm going to draw it in this plane. So this is the plane y equals 5. And then we have a circle. So this is x, and this is z. So I need to parameterize that. So to do that, I'm going to say, let's say that it's x squared plus z squared equals, I don't know, 20. No, I shouldn't use 25 because that's confusing with y equals 5. 16, right? Okay, so I know that it's a circle with a radius of 4 in the x and z plane, so I can actually do this. Let's see. I'm going to say x equals, y equals, z equals. So y equals 5. I don't have a choice about that. I live in the plane y equals 5 for this problem. Now, it's a circle with a radius of 4, so just do it. There was nothing sacred about x and y. We just always use them because those are like the variables that everyone uses. But this we could just make 4 cosine of t, and this we could make 4 sine of t. What I want you to do is I want you to go to GeoGebra. I want you to use the curve command, type that in, and see what you get. And then to make it clearer, after you've graphed it, after you've rotated it around and looked at it, also plot y equals 5, which will be a vertical plane that goes through y equals 5, obviously. And you'll see that we've done it. So this is a really powerful thing. And because we know so much about parametrics, we can do a lot of stuff now in 3 dimensions. So it's good that we learned it. All right, let's keep going. So z equals 4, parallel to z equals 0, which means it's, so z will be missing, so it'll be the xy plane, which I overthought that. So parallel to the xz, oh no, the xy plane. And now I want an ellipse, right? So let's see. We know how to parameterize an ellipse, I think. So I'm going to say x is, y is, and play around with the center, you know, change up things, see what's happening. I'm imagining that you're graphing all of these things in GeoGebra. Go for it. So z equals 4, we have no choice. I'm going to say x is, so it's an ellipse, right? So we use sine and cosine still, cosine and sine. Let's go with 3 plus 2 cosine of t. And then y will be, I don't know, -5 minus 4 cosine. Oh, not cosine. What are you doing, man? Sine of t, right? You got to vary it up at least, one in the other. So we get this. We're not always interested in the way that these rotate. So like the choice of cosine and sine is a little less important, because what we want you to do is just be able to deal with them. I think I'm going to stop here, and I will come back and do the rest of these in the next video. I have no idea how long this is, so I will be back.